Hello everyone, my name is Kaunin Fatima from India University, and today I will be presenting to you my study which is titled Enhancing Multi-Class Document Classification with Layout Language Model, a comparative study of version 1 and version 2. So the contents of this presentation consist of the abstract of the paper, introduction about the study, discussion of some of the related works to the study, the proposed methodology, the architecture of the model, results and discussions. Finally, we will conclude the presentation with the conclusion and some of the possibilities in the future. So the paper presents the application of layout language model to automatically extract information from complexly organized text and examines the significance of effective information retrieval in many fields. A subject of the RVL-CDIP dataset, which actually includes 400,000 photos arranged into 16 classes with a cap of 200 images per class, which is used as the subject of this study. There are three sets of the dataset: training, validation, and testing. The papers are categorized using LayoutLM version 2 and version 1 with accuracy rates of 80.94% and 68.75% respectively. The study demonstrates how well the layout language model analyzes and comprehends a variety of document forms and contents. So, in the modern data-centric processes, data digitization and information extraction are essential. Information extraction is made difficult by the abundance of unstructured document data generated by business activities. So the scanned photographs and digital documents, which include a range of categories, such contracts or industry reports and purchasing, are the paper's primary focus. So the layout language model tackles the difficulty of extracting meaningful information from complicated document layouts. It is developed for natural language processing, which is NLP, and text recognition in complex layouts. So for users, including comprehension of text and providing answers to visual queries, in addition to classification as well. Numerous strategies such as deep learning methods like CNNs, RNNs, RNTNs, and RCNNs have been investigated. So there is a study which discusses the layout transformer model, which is also known as LILT, which is actually a hybrid technique for structured document interpretation, and it uses the extraction of text with bounding boxes and contents from input document pictures. So this model actually also uses the commercial OCR engines. There was another study which was conducted as a comparison between LayoutLM and Donut, which reveals that the LayoutLM's performance is superior in image classification across different datasets while compared to the Donut one. And there are other subsequent investigations which explore the integration of textual and visual input into a single classification task, attaining a great performance using the publicly available dataset, which is RVL-CDIP. So the proposed methodology shows the data description, which is the RVL-CDIP dataset. This is a freely available, publicly accessible, and consists of document images used for testing various models, including those for document classification, information retrieval, and question and answering systems. So this contributes to the training of several models. However, because of technological limitations, only a tiny portion of this dataset is used in this research. And for the data preparation, text from the images is converted into machine readable English using Tesseract OCR in the research for the layout language model version 2, which incorporates text, image, alignments, and matching jobs with an attention mechanism. So, using truncation for lengthier inputs, padding for uniform input length, and label indexing via dictionaries have been done, which is the IDX2 label and label to IDX for the numerical representation of class labels. We employed a variety of Hugging Face transformers libraries as well. While the model architecture is the same in all versions, LayoutLM version 2 leverages visual information early in the training process by integrating Tesseract OCR and visual embeddings during pre-training itself. When we come to talk about the model architecture, we know that the LayoutLM version 2 model, it actually involves three different forms of embeddings, which are text, visual, and layout, which uses transformer architecture in addition to self-attention for enhanced modeling. Following the merging of these embeddings, the model produces feature representations with the ResNet 64 into 4D serving as the visual foundation. The feature representation is used for either element level or token level categorization depending on the job. The Layout LM version 2 model, which is excellent at evaluating document layouts and associated tasks, is assessed after training and adjusted for maximum performance. Now, when we talk about the results and discussions, the metrics used to evaluate the performance of this model can be seen in the following. It consists of accuracy, precision, recall, and F1 score. All the metrics are compared between the two versions as seen in the table 1. And when we evaluate a classification model's performances, it can be evaluated by looking at the confusion matrix, which summarizes the model's predictions in terms of true positives, true negatives, false positives, and false negatives. We can see the differences in the matrices in the figures 2 and 4, where figure 2 shows the values when version 1 is used and figure 4 shows the values when version 2 is used. In figure 3 and 5, the micro-averaged ROC curve and ROC curve for multi-class classification for all the classes present in the dataset using the LayoutLM version 2 can be seen respectively. This table compares the accuracies of all the classes that belong to the dataset. Now in our study, two versions of LayoutLM model were examined. Version 2 exceeds the version 1 with an accuracy of 80.94% compared to the 68.75% utilizing Tesseract OCR for document encoding. Finally, we demonstrate how LayoutLM version 2's use of both visual and spatial features makes it the best option for employing of model involving visually rich documents. Future research on the third iteration of the model and its enhancements through various ways is anticipated by our study. This suggests a viable path for using hybrid techniques to improve accuracies in document AI applications in the future. Thank you very much for giving me this opportunity.